Okay everyone, so in this video I'm going to explain the solution for your quiz. Okay, so this is your quiz in the e-learning. Okay, so this is these are the equations. Okay, and then so I copied it here. Okay, and then as you guys might have known, okay, you have to put it in augmented version. Okay, so the augmented version of these equations are this one. For -8, 0, 1, -3, -1, 6, 3, 4, -6, 8, 0, 0, -1, 3, 4, -12. Okay, so to use Gauss Jordan, remember you have to start from column by column. Okay, so the first column, okay, this is the leading entry, it's already 1. Okay, and when you refer to reduced row echelon condition, you have to also make this into 0. Okay, so start with the first column. Okay, so make that into 0. So for this one, you can transform R3 using this minus 3R1. Okay, because this is the pivot equation. Okay, so use R1, okay, for transforming the third row. Okay, so and using that, okay, then this is how your matrix will be after that step. Okay, only the third row will transform. 1, 3, 1, 6. So this now has become 0, 4, -12, -4, 24. And then the last row is still the same, -12. Okay, now moving on to the next column. So now we can say that this is the leading entry, it's already 1, so you don't have to transform that. Okay, now you have to make these two elements into 0. Okay, because only the leading entry can be the non-zero entry in its column. Okay, for it to be called a reduced row echelon form. Okay, so for that one, okay, you transform R3 and R4. Okay, by still using this. Oh sorry, you should use row 2 now. Okay, this is your pivot equation. Okay, use R2, not R1 anymore. Okay, so R3 minus 4R2, then you can zero this element out. Okay, and then for R4, R4 plus R2. Okay, -1 plus 1 equals to 0, right? Okay, so you can use that to transform these two elements here. Okay, now and the next step, your matrix will look like this. 1, 2, okay, and then the third row will become this, and then the last row you will get that. Okay, so after the third step, the third transformation, you will get this. Okay, so just to check, so this is the leading entry for the first column. Okay, and this is the leading entry for the second column. Okay, now we're moving to the third third leading entry for the next column lah. Okay, and as you can remember, the condition for a reduced row echelon form, okay, all a row with all 0 elements, okay, should be at the bottom of the matrix. Okay, so you have to swap this first, okay, and then you do the transformation for the next leading entry. Okay, so this swap, okay, then you will get this one. If you don't swap the rows, okay, I can deduct your marks, okay, because if that is the case, then you're not solving it in reduced row echelon form. Okay, but you cannot just omit this, you still have to write it down. Okay, so like that. Then you find the next leading entry. Okay, since the third row only the only entry it has is in the last column, okay, so this shall be the leading entry for the third row. Okay, so transform that into 1 lah. Okay, this should be 1. Okay, for you to do that, okay, so just transform R3 by dividing R3 with 3, then you will get 1. Okay, so it's 1 to 4. I just copy the other rows. -8, 0, 1, -3, -1, 6. So all this 0, 0, 0, 1, -2. Okay, after that step, okay, so this is what we call as reduced row echelon form. Okay, because okay, the leading entry must be 1 for each row. Okay, and sorry, oh no, we have another step, sorry, we have to zero this first. I forgot. Okay, you have to zero this first. Okay, these 2 elements. Okay, zero this, and then solve by using back substitution. Okay, I believe you can do this. Okay, so solve for R1 and R2. Okay, transform it. I'm not going to show it here. Okay, you can do that, the last step. Okay, and then when using this, okay, the solution is going to be so you will get x1 equals to -2, x3, x2 equals to 4 plus 3x3. Okay, and you can, x3 is actually free, okay, can be any value. Okay, and x4 is -2. Okay, try, I believe you can try solving the last 2 steps by yourself. Okay. Okay, so that's it for the quiz. Okay, if you have any question, then you can ask me in the group.